Lytle here with Camera Lab at Cal State Channel Islands, and I have with me, as always, my intrepid cameraman Michael. Today we're talking about white balance, and I have this candle illuminating me because it has a color temperature to it. Michael told me recently, just a few seconds ago, that the camera white balance is set for 3,800 degrees Kelvin, and that is what these lights, which he is going to turn on now as I blow out this candle. Whoa! Okay, so what does white balance mean? And for any of you in class who have been shooting and you have not used your white balance properly, you're probably noticing that what's happening is you're getting blue or red or orange or even maybe green. I guess you would call it a filtration of some sort, or a color bias on your images. That's because you are not thinking about the kind of light you're shooting in. And I have here on the table some different light bulbs and light sources. I got this charcoal because I need to talk for just a quick sec about this amazing scientist in the 19th century who called himself Lord Kelvin. That wasn't his real name, and I can't remember it off the top of my head. But basically, he was interested in thermodynamics and came up with a temperature scale that can be used along with centigrade and Fahrenheit. And if memory serves me correct, the differences is between Fahrenheit and Kelvin as you add 273 degrees to it to make it to go back and forth between Kelvin and Fahrenheit. Centigrade's much more difficult. Anyway, what he did, I digress. He took what was called a black body. This is a chunk of charcoal that you'll find in your barbecue. And he heated it up. And as he heated up this black body, which was a cube of graphite, it wasn't charcoal, he found that it changed colors the more energy that was put into it, the hotter it got. So it started off as a kind of an orange, red, yellow, and then it went slowly into blue up into white hot. And he assigned degrees to that, degrees of Kelvin. And it is the way your eye perceives the color transmitted from this energized source, which are, of course, these lights here. And I brought a tungsten light. This is the old-fashioned tungsten light with the filament in it. This is contraband now, but anyway, the tungsten filament, when it's energized by the electricity, heats up at about 2,800 to 3,200 degrees Kelvin. So it is orange in output, but our brains are constantly adapting to that. So we don't really notice the change in color. And you probably would only notice this if, say, you had this in your lamp and it blew out and you instantly put in this LED and you would see this as being a warm light, and you would perceive this as being a blue or cold light. Once again, they do alter some of these bulbs so that to try and simulate daylight. I'm going to get into that in a sec. But you recognize this is a fluorescent tube. This is around 3,000 degrees, 3,600 degrees Kelvin. This is a compact fluorescent, so it's the same. So it's more than this. You find tubes that are cool white or warm white. And then nowadays we have the LED bulbs, and they are usually balanced towards daylight. So that's 5,600 degrees Kelvin, which is, of course, the temperature of the sun. So on your camera, when you go to white balance setting, you will see a whole bunch of different, which we'll be putting up here on the screen for you behind me, the different symbols of white balance and what those mean. So you'll have AWB, which is automatic white balance. And if you remember, your camera is a computer. And so the camera, once you tell it the white balance setting, is always trying to compensate for the wavelength of light that's coming into it. And if I have it on automatic white balance, the camera's looking at the whitest white in the picture and trying to compensate for that because it knows in general that it's visible light somewhere between 3 and 7,000 degrees Kelvin. That's pretty cool. I mean, it's amazing. Once again, in the old days with film, you only had two choices. You could have daylight balance film if you were using color, and you would have tungsten balance film if you were shooting in tungsten light. And that was it. Otherwise, you had to put a screw of filter onto the front of your lens to compensate for any other light source. And obviously, in black and white film, or if you shoot in black and white, color balance doesn't matter because it's not affecting the overall color. So anyway, you will have automatic white balance. The next setting, you will see a sun symbol, and that means you're shooting out in daylight, which is 56 to 6,000 degrees Kelvin, and that will make everything look correct. Once again, your brain is always compensating for this, so that's why you wouldn't really notice it. The camera does, though. The next one you'll probably find is the tungsten bulb, like this, a little bulb with, pretty soon probably that will be gone because I don't know how much longer tungsten lights will be around. But you would set that if you're using a tungsten bulb. If you are using a fluorescent, you will see a tube, like the tube here. And there's different settings for those depending on whether it's warm white or cool white or the various kinds of fluorescent bulbs. So you would change those to make sure that you're getting what looks to be correct color. And LEDs, probably you would set it to sunlight, the sunlight setting. But once again, you would have to mess around with it. You'll also see white balance settings for clouds. You'll see a cloud. The reason for that is in the shade, when light hits it and scatters, it shifts a little bluer as it does on overcast days. And so you have a more blue tone overall. And so you can compensate by setting it to the house symbol with the cast shadow, like that. It's the way you're supposed to do it. We taught that in school. Anyway, the cloud or the shadow to compensate for that blue. You will see two triangles with a little notch or another triangle above. That's a custom white balance setting, which we're not going to get into because it's a little complicated to use. You have to use a neutral card to set it, and it gets into a whole different thing. And you may have a K, which is Kelvin, degrees Kelvin, and when you set it to that, you may be actually able to rotate through one of your dials to get the actual degree Kelvin perfectly set, which once again, probably too much at this point to mess around with, but it's something maybe as you get more advanced you might want to check out. Oh, and you'll see a flash symbol, which looks like a lightning bolt with an arrow on the end. And if you're using external flashes, which you would hook up to your camera, that's set for that, which is a little bit different than daylight. As you see, I'm wearing a periodic table, and there's xenon. And that's what is in a flash tube, is xenon gas, and it shifts blue. You can see, can you see blue? Can you show them the blue there?
Got it.
Oh, it's amazing. Okay, excellent. So the xenon gas is a little bit different, and so that's why you would set it to the flash. All in all, you can always shift to the AWB, the automatic white balance. That may really suit you and solve all your problems, although you may find a color bias in that. So anyway, that's it. Once again, if you have any questions, you can always ask me in class. And I guess that's it for white balance. Thank you.